In this video, we're going to be talking about naming acids. So in this class, in General Chemistry 1, any compound where the first element is hydrogen will be an acid. So the first element in an acid is going to be hydrogen. So the next question we need to ask ourselves is there also oxygen? So if we answer no, that means we need to follow our binary acid naming conventions. So when we're naming a binary acid, we're always going to include the prefix hydro, then the root of the second element. Remember, our first element will always be hydrogen. And for our ending, we'll change the ending to IC and always include the word acid. So if you see HCl, you would follow the conventions. You'll include the prefix hydro, the root of this element, chlor from chlorine. Then we change the ending to IC, ic, and include the word acid. So this would be hydrochloric acid. If there is oxygen, we're going to follow our naming rules for an oxyacid. Now, an oxyacid will always come from an oxyanion. So this would be something like chlorate, hypobromite, something of that nature where it's already includes the oxygen. So all you'll do in this instant is you're going to change the oxyanion's ending and then add the word acid. So if the original ending in the name of your oxyanion is ate, you would change it to ic, and if it's ite, you would change it to us. So in this example, it starts with an H, so we know that it's an acid. So we're going to take care of that by writing the word acid in our name. Now we're done with hydrogen, so we can just ignore it from here. So now we're going to look at just the second ion, my oxyanion, which is ClO. And if we know our ions, we know this is the hypochlorite ion. So all we have to do is change the ending. We're going to take this ITE, get rid of that, and change it to the ending OUS. So if I see the formula HClO, I know that that is hypochlorous acid. We do have some extra rules. So when it comes to our acids, we're going to treat them just like we do an ionic compound. So that means we're always going to have a net charge equal to 0. That's okay in this case because that means most of the time we're going to be balancing out just the hydrogens. So we're not going to have to worry about parentheses around any of our polyatomic ions, any of those oxyacids. You don't need parentheses because you'll only have one of that molecule and you'll have multiple of the hydrogens. So like with sulfate, it has a -2 charge. That's why I needed 2 of my +1 hydrogens to balance that out to get a net charge equal to 0. So just make sure that you balance out your hydrogens. The other rule that we have that's kind of different is that we do have 2 elements that get root element name exceptions. And those elements are sulfur and phosphorus. So the root in the acid name, if it includes sulfur, is sulfur. It keeps its whole name. The root for the element phosphorus is phosphor, so it keeps one extra syllable. So going back to this example we have over here, we had to have 2 hydrogens to balance out the charge of my anion. So that takes care of my first exception. Looking back at this example, we have sulfate and hydrogen. So again, we needed 2 hydrogen ions to balance out the -2 charge and get a net charge equal to 0 for my overall compound. So this would be the formula. If I was writing this formula, it comes from my sulfate ion. Since that has sulfur in it, even though it's sulfate, we're going to include the entire root sulfur and then use the ate ending for the acid, which again is ic. Ates become ic, and add the word acid. I hope this helped.